Good evening. So in this video I'm going to explain the testing of hypothesis procedure with an example. If you see this example, the heights of 10 males of a given locality are found to be 176, 169, 156 and so on. Based on this sample of 10 observations, 10 items, test the hypothesis. It clearly mentioned that test the hypothesis that the mean height of males is 170 centimeters. He is asking us to test whether the average height of the entire male people is 170 or not. So first of all, we need to understand that this problem is coming under a small sample problem. It's coming under small sample problem because it's our sample size n is less than or equal to 30. Got it? And coming to the second important point, is asking us to find out, he is asking us to test whether the mean height of males is 170 centimeters or not. So after observing the entire data, we can understand that this problem is coming under t-test to test a claim called the average height of males is 170 centimeters. So first of all, I am writing the given data. So given that n is equivalent to 10 and the general mean mu is equivalent to 170, this we need to test, and sample mean x bar is equivalent to sample mean x bar is equal to sum of the observations by number of observations. So sum of the observations means sum of all these values like 176 plus 169, 156 and so on. 176 plus 169 plus 156 plus so on plus 164, last one 164 by 10. So this will give us, so sum of all these values is equivalent to 1650 divided by number of observations nothing but 10, which is equivalent to 165. So this is called sample mean. And also we need to find out standard deviation. So it's a small number of observations, so standard deviation is representing by S, which is calculated by square root of summation of x minus x bar whole square by n. So this is the formula for standard deviation. So we need to find out, so we need to subtract this 165 from every observation, then we need to go with squares and by n. So this implies, see for example first one, x means first observation is 176, that means 176 minus x bar means 165 whole square plus second observation is 169 minus mean 150 whole square plus so on plus the last one is 164 minus 165 whole square whole divided by 10. So this is the way of calculating standard deviation. So I have applied this formula. So that means summation of x minus x bar whole square by n, that means from each observation I have subtracted 165 and I have applied square. For example, first one is 176 minus 165 is nothing but 11, that 11 square means 121. Similarly, the second observation is 169 minus mean, arithmetic mean 165. So this is 165. Okay, so 169 minus 165 is equal to 4. So if you do square for 4, it is 16. Coming to third one, 156. So 156 minus 165 is equivalent to minus 9. But minus 9, if you do square, it will become 81, and so on. Likewise, for all the 10 values, I have applied the formula. I have got root 645 by 10, which is equivalent to 8.05. So now I have everything. I have sample size, specified mean, sample mean, this is sample mean, this is standard deviation. Now we can go for the procedure of testing of hypothesis. As we know that in step 1 we have to go for null hypothesis bracket lo H naught. As we know that while writing the null hypothesis, we need to take, let's take the claim as true. So the claim as true, that is H naught is hyphens 2, mu is equal to, what is asking us to test? Is asking us to test what is the mean weight of the male is 170. That means he is asking us to check whether mu is equal to 170 or not. So we are assuming that mu is equal to 170 as true. So this will be called as null hypothesis. Now coming to the step 2, we have to write alternate hypothesis within the brackets H1. So alternate hypothesis is always opposite to the null hypothesis for this statement. That means H1 will become, so this is equal now, so obviously mu will be not equivalent to 170, will be taken as the alternate hypothesis, because if mu is equal to 170, if mu is not become 170, then it might become less than to 170 or more than to 170. So that can be written as not equal. Coming to step 3, it is level of significance. Step 3, level of significance is it is not given in the question. Generally we will assume as, let's take level of significance as 5%. Okay, in step 4, as we know that it's a small test problem, so the formula is T is equal to x bar minus mu divided by sigma by, here sigma means S, standard deviation S by root n minus 1, root n minus 1. This is the formula. Now T is equivalent to, what is x bar? X bar means sample mean. Sample mean we have obtained as 165. 165 minus mu is nothing but 170 whole divided by S means standard deviation. We have got 8.05 divided by root of n means 10 minus 1. This implies 165 minus 170 means minus 5 divided by 8.05 divided by root 10 minus root 9. Root 9 means 3. This implies minus 5 divided by 8.05 divided by 8.05 divided by 3 will give you 2.68. This implies minus 5 divided by 2.68 will give you minus 1.86. So T cal is equivalent to minus 1.86. But remember, the most important, whenever you have negative value for test statistic, then we have to check our alternate hypothesis. In the alternate hypothesis, if you have not equal, then we call it as two-tailed. So whenever we have two-tailed, then we have to take modulus for calculated value. We have two-tailed in step 2. So we need to take modulus. We need to take modulus for calculated value. So T cal is equivalent to modulus of minus 1.86. This will give us 1.86. Now we have to take table value na. So T tab is equivalent to T tab at the rate of 5% LOS is equivalent to. So if you take T table, you can download it from the Google. So at 5% LOS, and the degrees of freedom is nothing but n minus 1, that is equal to n minus sample size 10, so 10 minus 1 9. At 9 degrees of freedom, for at 5% level of significance, the table value is equal to 2.62. Now our calculated value is 1.86 and table value is equal to 2.262. Now we can write our conclusion. So here T cal is less than to T tab, that is 1.86 is less than to 2.262. So this means therefore our null hypothesis H naught may be true, because our calculated value is less than to table value, so our H naught may be true and it may be true and accepted. So whatever H naught we have taken in this example, that means the claim is true. Claim means what? The mean height of the males is 170 is true, therefore we are accepting that into reality. Hence the mean height of the males is 170 centimeters. That's it. This is the answer.